Our first topic as we explore the idea of number theory is what are prime and what are composite numbers. So these are the numbers that we are going to be using most of the time. So number theory is a branch of mathematics primarily concerned with natural numbers and their properties. The natural numbers are given by this. I think we explored this earlier in our class, but in case you are new here and haven't seen that, the natural numbers, first we notate them with a capital N, and the natural numbers are the set of numbers that start with the number 1 and increase by increments of 1, and they do that forever and ever. And it's, rather than getting tired of writing this, I'm going to use what's called an ellipsis, 3 dots that indicate that we are going to keep following the same pattern forever and ever. So one of the first things we want to do is we want to talk about the idea of divisibility. How are natural numbers related to one another? So the definition of what's called divisibility for two natural numbers, A and B, we said that A is divisible by B if by dividing A by B results in a remainder of 0. So for instance, some examples, 24 is divisible by, say, 6, because when I divide 24 by 6, I have a remainder of 0. It goes in exactly 4 times. 15, well, what's a number that 15 is divisible by? I'm going to write down 5. Now, there are other options for these blanks. I'm just picking a particular example. 100 is divisible by 25. Okay, so in each case, I have said that 24 is divisible by 6 because dividing 6 into 24 or dividing 24 by 6, remainder of 0. Same thing for 15 and 5. Same thing for 125. The notation, if I want to write it another way, because math people, remember, love to have shorthand notation, I would say if 24 is divisible by 6, I would write 6 divides 24. This bar right here means divides into. 15 is divisible by 5, so 5 divides 15. And then 100 is divisible by 25, 25 divides 100. By the same token, if I have a number that's not a divisor, for instance, 24 is not divisible by 7, I would write 7 does not divide 24. And so that's just a little bit of the notation. So there are some common ways to test for divisibility for some smaller, more commonly used numbers. So we're going to just approach a few of those. So right here, you see a chart for common tests for divisibility. I'm just going to read through these real quick. I know you can read them just like I can, but we are going to have some examples using this. So how do I know if a number is divisible by 2? Well, the last digit's even, meaning it is the digit 0, 2, 4, 6, or 8. Those are the even digits. How do I know if a number is divisible by 3? Well, if I add up all the digits and it's divisible by 3. Divisible by 4, I look at the last 2 digits if they're divisible by 4. So if I have a really long number, all I have to do is look at the last 2 digits. To see if something's divisible by 5, you just look at the last number if it ends at 0 or 5. 6 means that a number is divisible by 2 and 3. So you would do both of those tests. The last digit's even and the sum of the digits is divisible by 3. To see if something's divisible by 8, we skipped 7 because that test is kind of complicated. It's more trouble than it's worth at our level of math. So 8, the last 3 digits are divisible by 8. 9, the sum of the digits divisible by 9. 10, it ends in a 0, and 12, it ends in a 3 and a 4. So here's what I'm going to have you do. I'm going to have you push pause on this video, and I want you to use the rules in this chart in exercise 1. There are 3 examples, and I would like you to determine in each of those examples if the number is divisible. So for instance, the first problem says 4 divides 3,754,084. I want to know, is that true or false? Does 4 divide it, or is 4 not a divisor? Use the properties. Same thing for the other two. So push pause on your video. I'll be right back. All right, I hope you have taken time to do the problem and you didn't just sit there waiting for me to do it. Remember, learning means that you actually have to process this stuff. And one of the ways we process is by writing and by doing. So I hope you did it. If not, I don't even know why you're bothering to watch the video. So 4, does it divide into this number right here? Well, from the table above, to determine divisibility by 4, we look at the last 2 digits. So I'm just going to look at the number 84. So 84, does 4 divide into 84? Well, 4 goes into 8 twice. Bring down the 4. 4 goes into 4 once. I have a remainder of 0. So since 4 divides into 84, 4 indeed divides into that whole big number. So that is going to be true. I want to know if 9 divides into 4,119,706,413. All right. So what we do for 9, the test is listed right here. We add up the digits and see if that's divisible by 9. So I'm going to add up the digits. 4 plus 1 is 5, plus 1 more is 6, plus 9 is 15, plus 7 is 22, plus 0 is 22, plus 6 is 28, plus 4 is 32, plus 1 is 33, plus 3 is 36. So the sum of the digits in that number is 36. And so I want to know now, is 36 divisible by 9? Well, it is. 4 times 9 is 36, remainder of 0. So again, for B, it's true. And it's true because 9 divides into the sum of the digits. Last one, I want to know, is that number right there divisible by 8? 677,838. Well, for the test for 8, I look up at my box. The last 3 digits are divisible by 8. So I only have to worry about 838. So let me come over here to my scrap work, 838. And I'm going to see, does 8 divide into that? Well, 8 goes into 8 once. Bring down the 3. 8 does not go into 3, so I bring down the 8. 8 goes into 38. That's going to be 4 times. But look at this. I have a remainder this time. So since there's a remainder, 8 does not divide into this number. So the answer is false. It is not divisible. All right, we're going to flip the page. There's a couple more examples on this page. I want you to pause the video once again, and I would like you to determine, is 5, is it a divisor of 562,122,835? And then is 6 a divisor of 48,323? Be back in just a moment. All right, once again, you're unpaused. I hope you did the problems and now you're checking your work. The rule for divisibility by 5 is the number ends in a 0 or 5. Well, there's my number. The last digit is a 5. So that means if I did do the division, if I took my calculator, true, it would be divisible. And just to show you, here's my calculator right here. Okay, and I'm going to put in 562,122,835. We're going to divide by 5. And if I am correct, if it is divisible, the remainder should be 0. We should not have a decimal. So, oh, look at that. It's perfect. So we ended up with a number without a decimal after we divided. Does 6 divide into 48,323? Well, the test is, for 6, it has to be both divisible by 2 and divisible by 3. Well, first, divisible by 2 means the last digit's even. Well, right here, the last digit's odd. The last digit is 3. So that means it's not divisible by 2. I don't have to test 3. Okay, so that is false. It is not divisible. All right, so those are the rules for divisibility. They help us get started identifying what's called factors of a number. So for instance, in part D, 5 is a factor of this number, 562 million, and all the rest of it. And we're going to use that because it's going to be a tool for us to find what's called a prime factorization. And so first, before we talk about prime factorization, I've got to define for you what a prime number is. A prime number is a natural number greater than 1 that has only 1 and itself as factors. So for instance, a couple small numbers that we know are prime numbers, like 2 is prime because the only factors are 2 and 1. 3 is prime, the only factors are 3 and 1. 7 is prime, the only factors are 7 and 1. And I could list some others, but there's a fun little trick. This is called the sieve of Eratosthenes. I can't say that. Okay, it's a mouthful. Maybe you can, and that is wonderful. And there is a way to determine all the prime numbers from between 1 and 100. And I'm just going to do this real quick so that you have a nice little list. I'm going to zoom out just a touch for this little bit of our time together. And so what you do in this sieve, a sieve is just a process, it's a fancy word, is we are going to go and we're going to find each prime number, and we're just going to cross out all the numbers that that prime number is a part of. So for instance, first thing I'm going to cross out is 1. 1 is not a prime number by definition, so I cross it out. And so what that means is the first prime number is 2. The only factors are 2 and 1. And so now what I'm going to do, and what I want you to do, is we're going to go and we're going to, every second number we're going to cross out, because it's going to be something that 2 is a factor of. So 4 will cross out, and then 6, and then 8, and 10. And so this is going to take me just a moment, so bear with me as I do this. I'm crossing out all the even numbers now. All of these numbers I'm crossing out are not prime numbers. Okay, so crossing. And you can have conversation with somebody while you're doing this. It's great fun. There we go. All right, we're almost done with the number 2. So all these numbers I'm crossing out have 2 as a factor, so they are by definition not prime. So the next number I see is 3. 3 is the next prime number. So now what I'm going to do is I'm going to count every 3. And if it's not already crossed out, I'm going to cross it out. It's not prime. So 1, 2, 3, 6 is already crossed out. 1, 2, 3, 9, we'll cross it out. 1, 2, 3, 12. 1, 2, 3, 15. 1, 2, 3, 18. 1, 2, 3, 21. 1, 2, 3, 24. 1, 2, 3, 27. 1, 2, 3, 30. 1, 2, 3, 33. 1, 2, 3, 36. 1, 2, 3, 39. 1, 2, 3, 42. 1, 2, 3, 45. 48. 51. 54. 57. 60. 63. 66. 69, 72, 75, 78, 81, 84 is already crossed out, 87, 90, 93 I'll cross out, 96 is already crossed out, and lastly, 99. So what we did there is we crossed out all the multiples of 3, so those can't be prime numbers. So now going through my list, the next number that's not crossed out is 5. 5 is the next prime number. And then we would go through and cross out all the multiples of 5. I'm going to try to do this a little quicker. So here we go. So we've got 10, and then 15, and 20. 25 is not crossed out yet, so I will. 30, 35 will cross out. 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, and 95, 100. I crossed out all the multiples of 5. And so you can see how the sieve works. Now the next number that's not crossed out is 7. This is going to be the last one I do, and I would just invite you to go ahead and finish this to see what are the other prime numbers between 1 and 100. So now we cross out every 7. So 7 more is 14, already crossed out. Then 21, already crossed out. 28 is already crossed out. 35 is crossed out. 42 is crossed out. 49, cross it out. 56 is crossed out. 63 is crossed out, 70 is crossed out, we'll cross out 77, and then 84, and then 91 will cross out, and then 98 is already crossed out. And that is called the sieve of Eratosthenes. Sorry about that. I'm not Greek. My tongue gets tied by that number. You can see the next prime is 11, and we could keep going, but I'm going to leave the rest to you. So when you're done, list out the primes that are less than 100, and I have that written here on my notes. The primes that are less than 100, this is what you get when you go through the whole sieve, is going to be this. It's going to be 2 and 3 and 5 and 7 and 11 and 13 and then 17 and then 23 and then 29, and then they gradually get rarer and rarer for us. And then the next one is going to be, when you go, the next one is going to be 31 and then 37. And then going, we've got 41 and 43 and then 47. And then, let me see, I got to do the sieve. I probably should have done this in advance, so I apologize. So if I did 13, 13's the next prime. So let's see, 11, 22, 33, 44. All crossed off. Great. 13, the next one's 26, and then 39, and then 49, 51. Yes, we already crossed that out. 63, and then 70, 76, and then 89. Anyway, sorry about that. I'm going to leave the rest to you on that sieve to cross out the rest of the primes. So we're going to flip the page to the next one. And so what we want to do with these prime numbers that we have right here that I was listing, 2 and 3 and 5 and 7 and 11. I don't know what happened to my list. That is my problem here. So that is quite the bummer that I lost my list of prime numbers. So sorry about that, everybody. Anyway, I'm not going to belabor the point. So 2, 3, 5, 7, 11, 13, 17. These are the prime numbers that begin the list. The smaller ones are the most common ones you're going to encounter. So let's flip the page. And so here's what we're going to do with this. We've got what's called a composite number now. A composite number is a natural number greater than 1 that is divisible by a number other than 1 in itself. So for instance, example 1 right here, this is a composite number 700. And what we're going to do is we're going to write it as its prime factors as we go through. So let's do that. And so what we're going to do is we're going to create what's called a factor tree. We're going to use the rules for divisibility, and we're going to break 700 down into its most basic parts. So looking at 700, 700 ends in a 0. So I know that 700 is 10 times something. Now feel free to use your calculator. I don't care. I can't stop you. This is an online class, so you're doing your homework. So 700 is 70 times 10. And now what we've done is we've broken that into smaller numbers that are easier to work with. So again, 70 ends in 0. So 70 is 7 times 10. 7 is a prime number. I'm going to circle it. 10 is 2 times 5. Those are prime numbers. And so my goal is at the end of each branch is a prime number. 10 is 2 times 5. Again. And so here's what's called the prime factorization of 700. It is 2 times 2. So I'm going to write 2 squared. 5 times 5, 5 squared, times 7. There we go. So here's what I would like you to do. I'd like you to write the prime factorization of 120. And while you're doing that, pause the video. And when you come back, I will have finished the sieve that we were talking about, and I will have the complete list of prime numbers because I'm a little embarrassed that I lost my notes and I didn't get to just write that down for you. All right, first off, I finished the sieve. And so here is the list of prime numbers between 1 and 100. Now, there are more primes. In fact, there is a math theorem that says there is an infinite number of primes, but we haven't necessarily found all of them. In fact, in the news recently, there was an article that they just found a new largest prime number. But that's neither here nor there. Here are the ones that are less than 100, 2, 3, 5, 7, 11, 13, 17, 23, 29, 31. We saw those. And then you can write down the rest, 37, 41, etc. Now, these are the numbers that you're mainly going to work with, probably even not some of the bigger ones. But the key thing for you to understand is that these are all prime numbers. Every one of these numbers, the only factor is 1 and itself. That's what makes a number prime. Okay, so back to the problem that I hope you had taken some time to do. We're going to find the prime factorization of 120. So again, 120 ends in 0. So I'm going to start with 12 times 10. Now, you might have the question right away, hey, Perkster, I saw that 120 was even, and I started with 60 times 2. Is that okay? Yes, there is more than one way to start, but we will all end at the same place. We will all have the same prime factorization. 12 is 4 times 3, or maybe you used 6 times 2 there. That's okay. 3 is prime. 4 is 2 times 2. Those are prime. Back up here to this branch, 10 is 2 times 5. No matter how you factored your numbers, whether you started with 60 times 2 or whether you did 40 times 3 or whatever you did up here to start with 120, however you broke these numbers down, here's what you should end up with. We have 1, 2, 3 2s, 2 to the third. We have 1, 3, and then we have 1, 5. There's my prime factorization. So then we have our first of 2 tools we are going to use with our prime numbers. The first one is called the greatest common divisor. The greatest common divisor is the largest number that divides 2 or more other numbers. Okay, this has some use for us. So the largest number that divides into 2 or more numbers. So what I'm going to do in this example is I'm going to find the greatest common divisor of 216 and 234. So what I'm going to do, what my process is I am going to break both of these numbers down into their prime factorization. So 216 is going to be 4 times something. I don't know off the top of my head, so I'm going to take this opportunity to use my calculator. 216 divided by 4 is equal to 54. 4 is 2 times 2. 54 is 6 times 9. 6 is 2 times 3. And 9 is 3 times 3. So again, no matter how you broke this down, 216 is equal to 1, 2, 3 2s, and then 1, 2, 3 3s. Now I'm going to do the same thing for 234. So 234, I'm going to come over here to the side and do my work. 234. Well, I see that ends in 4, so that's an even number. So this is 2 times 117. 2 is prime. 117, 7, 8, 9. The numbers add up to 9. So that means 9 divides into 117. So 117 divided by 9 equals 13. 13 is a number on that list of primes. So I know I'm done there. And 9 is 3 times 3 primes. So 234 is equal to 1, 2, and 2 3s, and 13. So I want the greatest number that divides into both. Okay, it's called the greatest common divisor, GCD for short. To find the greatest common divisor, what you do is you take the smallest power of each number. So for my greatest common divisor, they both share a 2. So I'm going to take the smallest power of 2, so just 2. They both share a 3, so I'm going to take the smallest power of 3. That's 3 squared. They both don't share 13. So I'm not going to include 13 at all. So I have 2 times 3 times 3, that's 2 times 9. 18 is the largest number that divides into both 216 and 234. I'd like you to do the same thing for exercise 4. I want you to break both of these numbers down into the prime factorizations, and then I want you to find the greatest common divisor, the largest number that divides into both. Push pause on the video. I'll be back in just a moment. All right, I'm back. I hope you took some time to do that problem. So 225, I'm going to start there. 225, it ends in 5, so it is 5 times something. And so in your calculator, we just go to, we're going to clear that out. We're going to say 225 divided by 5 equals, and that is 45. So those rules for divisibility help me because now I took a larger number, 225. I broke it down into something more manageable. 45 is, again, it ends in 5, so it's 5 times 9. Each of these 5s are prime. 9 is 3 times 3, which is prime. It's on my list. So 225 is equal to 2 3s, 3 squared, 2 5s, 5 squared. Now we're going to do the same thing with 825. So I'm going to start my work right here. Again, 825 ends in 5. So that is 825 divided by 5. And that turns out to be 165. 5's prime. 165 ends in 5. So it's 5 times something. So it's going to be 5 times 33. 33 is 11 times 3, both of which are prime. So we've got 825 is equal to 13 times 2 5s times 11. All right, so my greatest common divisor, the largest number that will divide into both, the largest number that has factors of both. So they have 3 in common. That's the word common in greatest common divisor. So I'm going to take just the plain old 3. You always take the smallest power. They have a 5 in common, so I need 5. And this is a tie, so we're going to take 5 squared. And then they don't have 11 in common, so I don't need anything else. So the greatest common divisor is 3 times 5, or 75. All right, we're going to flip the page. One more thing that we're going to do with our prime factorization. And so instead of the greatest common divisor, we're going to use what's called the least common multiple. Now, if you remember you're adding fractions, then we use the least common multiple all the time for my denominators. And so for the least common multiple, we do the same sort of thing. What you're going to do is you're going to start off first with your prime factorization. Now, in these first 2 problems that I've given you, or my example and your example, it's the same numbers we just did. I did this to save us a little time. So from my previous page, 216 is equal to 2 to the 3rd times 3 to the 3rd. And 234 is equal to 2 times 3 squared times 13. Now I'm finding the least common multiple, the LCM. So now what you do for the least common multiple is you take every factor you see and you take the most of it. So I see a 2, I'm going to take 2 to the 3rd. I see a 3, I'm going to take 3 to the 3rd. And then I see 13, so I'm going to take 13. And that is going to give me the lowest number that both 216 and 234 can divide into. So let's see what that number is, and let me show you. So here we go. So 2 to the 3rd is 8, times 3 to the 3rd is 27, times 13. That is the number 2,808. And so my contention is that number, I can divide both 216 and 234 into it. So 2,808 divided by 216, it goes with a remainder of 13. And then 2,808 divided by 234 goes with a remainder of 12. Or excuse me, goes 12 times, not with a remainder. So 2,808 divides both 216 and 234. All right, I'd like you to do exercise 5, please. Notice I've picked two numbers that we just used on the previous page. So I would like you to write down their prime factorizations and find the least common multiple. Pause the video, do that. We'll be right back. All right, so you've unpaused the video. 225 is 3 squared times 5 squared. That's from the previous page. 825 is 3 times 5 squared times 11. That's from the previous page. So the least common multiple, I'm going to take the most. I'm going to take everything that I see. So I'm going to take the most 3s, 3 squared. I'm going to take the most 5s, 5 squared. I'm going to take the most 11s, and that's 11. So 3 squared times 5 squared times 11. So 3 squared is 9, 5 squared is 25, times 11. That is 2,475. And again, you can divide both of those other numbers into that. So here's one with new numbers, exercise 6. So I'd like you to pause the video and do the prime factorization for 144, the prime factorization for 300, and I would like you to find the least common multiple of that, please. All right, I'm hoping you've taken time, you've paused the video. Now we're unpaused. So 144, it ends in 44. So I see that 4 will go into that and 4 will go into that. I don't know how many times, but that's what my good buddy, the calculator's for. 36 times. 4 is 2 times 2. Those are prime. 36 is 4 times 9 or 6 times 6. Then I've got 2 times 2 here. And 9 is 3 times 3. So 144 is equal to 1, 2, 3, 4 2s, 2 to the 4th, and then 1, 2, 3s, 3 squared. 300 ends in a 10, so 10 times 30. 10 is 2 times 5. 30 is 5 times 6. And 6 is 2 times 3. Remember, my goal is to get each of those to end in a prime number. So 300 is 1, 2 2s, a 3, and then 1, 2 5s. So the least common multiple, the smallest number that both 144 and 300 would both divide into, I'm going to take every factor I see. I am greedy for factors. So I'm going to take all 4 2s. I'm going to take both 3s, and then I'm going to take 5 squared. And I'm going to throw that down into my calculator. 2 to the 4th is 16. 3 to the 2nd is 9. 5 to the 2nd is 25. And that is 3,600 is the smallest number that both 144 and 300 divide into. One more problem with slightly smaller numbers, just so it takes a little less time. So just to wrap up this section, I want you to take the numbers 18 and 30. I want you to find their prime factorizations, and then you are going to determine for me what is both the greatest common divisor, meaning the largest number that divides into both, and then the least common multiple, meaning the smallest number both those divide into. So take a minute or two, pause the video. We'll be right back. All right, so 18. 18 is even, so it's 2 times 9. 2 is prime. 9 is 3 times 3. So 18 is equal to 2, and then there's 2 3s. 30. 30 ends in a 0, so it's 10 times something, 10 times 3. 10 is 2 times 5. Both of those are prime, and 3 is prime. So 30 is 2 times 3 times 5. So the first thing we're going to figure out is what's the greatest common divisor. For the greatest common divisor, you take the smallest amount of the things that they have in common. So they both have a 2 in common, so we'll take a 2. They both have a 3 in common, so I only want the smallest, so 3. And then they don't have 5 in common, so I don't want any 5s. And so the greatest common divisor is 6. 6 is the largest number. There's no larger number. It's the largest number that divides into both 18 and 30. 6 divides into 18 3 times. 6 divides into 30 5 times. The least common multiple. The smallest number that both of those will divide into. So again, you go back and okay, I need the most of everything that I see. So I need a 2. This time I've got 3. I'm going to take 3 squared. And then I see a factor 5, so I'm going to take a 5. And so that is 2 times 9, that's 18, and 18 times 5, I don't know off the top of my head, 18 times 5 is 90. So 90 is the lowest number that both 18 divides into and 30 divides into. And that will also function as a common denominator when we talk about fractions. All right, so practice those things. We are going to use them. And have a great rest of your day.